In the previous video, we talked about uh, some applications of anonymous functions and how anonymous functions can work together with the so-called function handles. Right? In fact, function handles is actually the only way to actually access one anonymous function. So in practice, usually anonymous functions uh, has to work together with the function handles, right? Um, and then we looked at how to actually, in most of our previous examples we have been looking at so far, the function handles are used as some kind of a container of a definition of a function, and then we can pass it around as some kind of data structure. So um, some kind of a data, right? But for all the examples that we have been looking at so far, we are using that kind of data as inputs to other functions, right? We're basically just using function handles to pass into another function as an input, right? So can we actually return a function handle from a function, right? So can we use a function handle as some kind of output of a function? Um, so in this video, let's start to look at some applications where return we can actually return a function handle as the output of a particular function. So so what we are trying to do is to actually uh, to to create a function that's going to return a function handle, right? Um, the example that we're gonna use is quite a simplistic. What we are what we're trying to do is to actually return a function handle that's pointing to a function that's gonna make just a simple line plots, by using the plot function. Um, so uh, so that's going to be what the function handle is going to point to, right? It's going to point to this kind of a particular function, right? But um, so to make the idea more concrete, let's try to work it out. And by working on this particular example, we're going to also look at another feature of Matlab, which is called a nested function. So we can actually write a definition of another function that's embedded inside of the definition of one function. So let's try to create a new function first, right? Um, we're gonna call this particular function. We're gonna call this particular function. Let's call it get underscore plot handle. Right. So that's the name of the function, right? And then the purpose of the output of this particular function is gonna be a function handle. Let's just call it h. That's gonna be our function handle. And then the inputs to this particular get plot handle is going to be the specifications about how you want the plots to be made. How the specifications of, for example, the line width, the marker, uh, the marker size, the marker color, that kind of thing, right? So if you want a function, for example, if you want a function that's going to make plots with line width, say 5, with a marker size that's like a 4, right? And then the purpose of this getPlotHandle function is to actually return a handle to a function that's gonna explicitly make those plots using those specified line width, those specified marker size, that kind of thing, right? So what's gonna be the inputs to getPlotHandle, right? The inputs to the getPlotHandle is sort of the specifications of the line. Let's call it line spec, right? That's supposed to be a string, basically. It's a line specification. And then line width, right? Line width, and then marker edge colors, for example, right? Marker edge color, that's one of the options that's accepted by the plot function of Matlab. And then marker face. So what's going to be the face color, basically? The face color. The marker is not just a symbol. It could have fill, color fill, right? So you can sort of fill up some color into the marker, and then marker size, right? Marker size. So that's going to be the total amount of input to this particular function. Right. So that's a normal function, right? Let's save it. Let's save this particular function, and then the default function name is going to be get underscore plot underscore handle, right? So Matlab cannot actually use space to separate the words. You must have a usually you use the underscore to replace the space, right? So now we have this particular file in our current folder. That's um, that's this particular function. Right. So the purpose of this particular function is to actually return a function handle, right? And that function handle must point to some kind of function. So what's actually the function that this function handle is going to point to? Let's define a nested function. What exactly is a nested function, right? A nested function is simply just a function definition that's embedded inside of the definition of another function. Right? You can put the definition of the inside function almost anywhere. It doesn't have to be in a particular sort of order, right? Let's just write our function here. Let's just write our function here. That's another function. So we have to use the function keyword again, right? And then followed by the usual definition. You are supposed to have output equal to the name of the function and then a bunch of inputs to that particular function, right? So for this very simple function that's going to just make plots, we are not going to return any output. So what we are going to do, what we are going to do is to just ignore the outputs first, right? Later on, if you want this particular function to return some output, you can do that, right? But for this particular simple example, let's just try to come up with a function that's going to return nothing, and then it's going to take two inputs. That's the data, x and y, the horizontal and the vertical axis, right? And then let's close the function first. Let's close the function. Right. And inside of this particular function, we're going to call the Matlab plot function, right? And then if you have forgot about how to actually use the Matlab plot function, you can always go back to the command window and type help plot. Right? Then it's going to tell you how to actually use the plot function. It's supposed to take at least two inputs, right? The x and y, the horizontal and the vertical axis, right? And then it's got lots of specifications about how you want the plots to be made. Right? X and Y is the data, and then that's the line style, right? And then the line width, marker edge color, marker face color, that kind of thing, right? Marker size, that kind of thing, right? So let's try to use the plot function. So the plot function is going to take two pieces of data, the horizontal and the vertical axis, right? X and Y, and X and Y are being passed into the geoplot function. So we can just use those two inputs to the geoplot function, right? X and Y. And then the next input is supposed to be the style of the line. So for example, in this particular example, it's using dash line. R means red. It's going to be red dash line. And then S means square, basically, right? So all the different points are going to be represented by using squares. And then between the individual neighboring squares, it's going to be dash lines that's going to be connecting the neighboring squares, right? So that's sort of the so-called line specification. That's the line specification, right? So how do we actually get the line specification? The line specification is being passed into the getPlotHandle function, right? This getPlotHandle function actually takes line specification as the first input, right? So if you have a line specification that's being passed into the getPlotHandle, this line specification, this ln spec, this particular variable, this particular container is actually visible inside of this getPlotHandle function. And this nested function called geoplot is embedded inside of this getPlotHandle. So geoplot actually can see line spec that's being passed into the getPlotHandle, right? So inside of this nested plot plot nested function, we can use line spec that's being passed into get plot handle, because this geoplot function is actually embedded inside of this get plot handle function, right? So that's a line specification, right? And then the next one is called line width, right? That's the line width, line width, line width. That's the next option that's gonna pass into the plot function. What's gonna be the line width, right? Again, we can use this line width that's being passed into the get plot handle function. You see, so I can just use line width. And then the next one is marker edge color, marker edge color, marker edge color, right? So all those strings that called line width, those marker edge color, all those strings that we specify here are option names that plot function, the Matlab intrinsic plot function is gonna recognize, right? So whenever we use the plot function, we can actually take a look at the user manual of the plot function. Then we can actually recognize those option values, those option names, basically. These are essentially key value pairs, right? So this is the key, that's the name of the option, and then that's going to be the value that's assigned to that particular option, right? So Matlab has this kind of convention. It's always like this kind of thing. It's option and then value, option and value, right? Option and then value. It's basically appears in these kind of key value pairs, and each of the value are going to be separated just by comma. This dot to dot, these three dots, means that there's a line continuation, which means the next line is gonna follow this line, right? But when we are writing the code, we don't want sort of our line to be sort of too long, so we use these kind of three dots to actually separate different lines, right? But in fact, this is actually one line of code. So this one line of code is actually this line, and then this line, and then this line, right? So this one line of code is being separated into like 4 different lines, just to make it appear visually, more appealing to the person who's going to read the code, right? But you have to recognize that this is actually one line of code. So if you don't want to separate them, that's completely fine, right? So marker edge color, we have an input to the get plot handle function. It's called mk edge, right? And then the next one is a marker face color, right? Marker face color, right? mk face. And then the next one is marker size. That's mk size, right? So basically, I am actually typing the entire thing as like a one line, but in practice, you don't have to do that. Maybe it's not a good idea to actually do that, right? Let's just separate it into like multiple lines. So one option, one line, basically, right? And then let's just put some this kind of thing as a line continuation, right? Right. And that's our inner function. That's sort of the definition of our inner function, right? And when defining this particular inner function, we are actually using the inputs to the get plot handle function, right? All the inputs that's actually specifying how the plot is supposed to be made are being passed into the get plot handle function, right? So the style of the plot is the input to the get plot handle function, right? And then we're using those inputs in the geoplot function that's kind of nested inside of the get plot handle function, right? And then we're defining this nested inner function in this particular way by calling the Matlab's intrinsic plot function. So once we have a definition of this geoplot function, we can return a handle. So now we can actually return the handle. Let's just the output of the getPlot handle function is going to be a handle to this nested function. H is going to equal to a handle to the geoplot function that's been created inside of this getPlot handle function using those style specifications, right? And now let's just save it. Let's just save it. So now let's take a look at how we can actually use this particular function, right? So we have the purpose of this particular function is basically to separate the data x and y. That's going to be drawn with from the specification of the line, from the specification of the plots, right? We don't want to sort of, if we are just using the plot function, we're basically mixing together with the data with those style specifications, right? But by doing things this way, there's a chance for us to actually separate the specifications of the style of the plot and the data, right? So now let's write a new script. Let's write a new script, and then let's try to use this particular function. So so let's write a comment first. Use function handle to separate plot style from plot data, right? So now let's do that. Let's do that. The first thing we're gonna do is to call the getPlot handle function. We're gonna call the getPlot handle to actually create a function handle to the geoplot function, right? So h is gonna equal to get plot handle, and then the specifications or the inputs to the getPlot handle function is gonna be the specifications of the line, right? So let's suppose we use dash dash rs, and then the line width, let's say it's 2. Line width is 2. We want a function that's gonna make line plots with a line width that's 2. And then the next one is a marker edge color, right? Marker edge color. Let's use black. Black, K means black. And then marker face color. Make marker face color. Let's use green. G means green. And then the last one is marker size. Marker size. Let's give it like 10. That's an integer, right? So by doing this call to the getPlot handle, what we have created is a function handle h that's pointing to a function that's gonna make plots. That's gonna make plots of any kind of inputs, right? Any kind of inputs, x and y, data, any kind of data, right? But with those kind of specifications as a style of the plot, right? So let's try to create some kind of fake data. So x equals to minus pi to minus pi to pi, say, right? And then with a stride of what? With a stride of pi divided by 20. Right, that's our x, and then what's gonna be y, right? Y is gonna equal to, let's just use some arbitrary function. Let's say tangent of sine of x, right? Subtract sine of tangent of x, right? I don't really know what this function is gonna look like, but let's make a plot and see what they're gonna what's gonna be the line, right? And then we can just use this h function handle and x and y as inputs to this h function handle, right? Let's do h. Don't forget what h is pointing to, right? H is pointing to what? H is pointing to geo_plot. And this geo_plot is going to take x and y, right? The horizontal and the vertical axis, the data points for the horizontal on the of the horizontal and the vertical axis of all the data points, right? So it's gonna take two inputs, x and y, x and y, right? And that's gonna be how we can actually use this h function. Let's just run it, right? And then let's just call it. Uh, so this is get plot handle. Let's call it use plot handle, right? Save it. So is it making the plot? Yeah, it's making the plot. Okay, so that's what the function actually looks like. It's a kind of a weird function, right? But it's actually made. But it's actually made using those line specification and style specifications that you specified here, right? So it's gonna be red dash lines that's gonna connect squares, right? S means squares, and then line width is gonna be 2, right? And then the marker edge color is gonna be black. So if you look at each of the square, that's the marker, right? The edge color is exactly black, and then the face color is green. The face color is the color that's gonna fill up each of the marker. That's green, exactly green. And then the size of the marker is 10. Right. So that's how you can actually use the get plot handle function. How you can actually use the get plot handle and then use the function handle that's returned by the get plot handle, right? So that's if you think about it, right? If you think about it, what's going to be the analogy? Suppose each of the function represents a small robot that's going to perform a certain function, perform a certain functionality, a certain task, right? Can we actually build those small robots using other robots, right? So get plot handle, you can think of get plot handle as a robot that's going to make other robots, right? So the stuff that's the function handle that's returned by this get plot handle robot is another robot that's actually made by this get plot handle robot, right? And what's actually this returned robot? This returned robot is going to make plots of different kinds of data using those kind of styles that's specified to the get plot handle robot, right? So get plot handle is essentially a robot that's going to make other robots, and the robots that's going to be made by this get plot handle robot are those job plot robots, and those job plot robots are going to take the data, the horizontal and the vertical axis of the all the data points, and then make plots using those kind of styles, right? So if you want to make a different robot with a different style, for example, you can do that. Right? Suppose I don't want a robot that's gonna just uh, uh, make plots using this kind of a specification. Suppose I want to change the specification of the robots, right? Let's do a H1. That's a different robot. H1 is a different robot, right? And then suppose I don't want to use dash line. I want to use a blue solid line, right? And then I want the marker to be say circle, right? Circle is a maybe O is a circle, right? And then so the edge color, let's change it to like red, and then the fill color, let's change it to black, and then the marker size 10, right? So H1 is another robot. It's a different robot, right? And this robot is gonna make plots using a different kind of style. So let's call H1 X and Y, right? Maybe let's create another figure, right? Let's keep the original figure, right? And then let's make another figure. Let's select this section and then execute evaluate the selection, right? So now it's gonna make it's a different robot, so it's gonna make those plots in a different style. The data is the same, but the style is different now, right? So the curve is still the same curve, but you can sort of see the style is different, right? Let's sort of still dock this particular figure. maybe it's not a good idea to actually use two different figures. Let's just use two different subplots, right? Let's create one figure, figure 1, and then let's subplot one row, two column, and the first plot. We're gonna do that, and then subplot one row, two column, the second one, right? H1. Let's run it. Yeah. Right. So that's the same data that's been sort of visualized using two different kinds of robots, and each one is actually configured in a different way, right? So that's how we can actually create robots that's gonna create other robots, right? So now let's look at some other functionalities that's kind of provided by Matlab. Right. When we talk about function handles, there are a few. There are two functions that's kind of quite useful. One is called str to func, and the other one is called func to str. Right. These two functions, these two intrinsic Matlab functions, are usually used in pairs. Right. One is called func to str. Right. So it's called construct a function name from a function handle. Right. So if you give a function handle to the func to str function, then it's going to return a string basically. Right. So here it's actually looking at some examples. So humps is a intrinsic function provided by Matlab. Right. At humps is actually a function handle that's pointing to the humps, right? And then it's going to return. If you use this function handle as the input to the func to str, it's going to return a string, and that string, the content of that particular string container called func name is humps, right? So sometimes when we are writing like a very large program, sometimes we could lose track of what's actually the name of the function that actually that's being represented by a particular function handle, right? For example, this particular the function that's represented by this h or h1 is actually pointing to this dual underscore plot, and this dual underscore plot is actually nested inside of this particular function, right? So maybe sometimes we could lose track of what's actually the name of that particular function, right? So let's use str to let's use so in this kind of situation, we can always use func to str to actually take a look at what's actually the name of that particular function, right? So suppose we do func to str h1. So it's going to tell us the output of this particular function is going to be a string, and the string is called a get plot handle / dual plot, which means what? Which means it's a function that's defined inside of another function. So it's going to use this kind of slash as a separator to indicate the different hierarchy of how the function is actually written, right? So suppose I do func to str at humps. That's the Matlab intrinsic function, right? That's going to just return humps, because humps is not really a function that's nested inside of any other function, so you're not going to see multiple levels. It's just like one level, right? That's func to str, and then there's also the inverse function. That's str to func. Let's do a help str to func, right? So str to func is going to construct a function handle from a function name. See? So the input to it is going to be a string, right? But then the output is going to be a function handle. So what Matlab is going to do is that it's going to search the current directory, and also all the different paths that's in Matlab's search tree, and then try to actually identify a function with the specific name, right? And then it's gonna try to construct a function handle from that particular function name, right? If it was able to actually find that particular function in the search tree and in the current directory, right? Um, so suppose in our script let's just use suppose let's call the str to func, right? Let's call the str to func. Str to func is gonna take a string as input, right? So let's give it a string. Let's get plot. So it's a function. It's a function name. It's a string that has the name that's identical to the function name, to the file name that's in our current directory. So Matlab is supposed to actually find it. It's supposed to be able to actually find this particular file, which contains the definition of the getPlot handle function, right? And then it's gonna return a function handle, right? Let's call it G. Let's call it G. Right. Right. So G is gonna be a function handle that's gonna point to getPlot handle function, right? If it's if the code is correct. And then we can actually use G, right? We can use G just like we use getPlot handle. So let's use G. Let's use G. G is gonna take the same set of inputs as the getPlot handle, right? And now let's specify the line style, right? So suppose we're gonna use a dash line, but with a let's use solid line with a black. What might be a good marker for us to use? Let's use diamonds. Diamonds. What might be a what's actually the letter for diamonds? I kind of forgot. Right. So if I forgot, let's just do help plot. Right. The menu page of plot is gonna tell me the different kind of symbols. Diamond is D. So that's D. So we're gonna use black solid lines to connect all the diamonds, right? And then line width is still 2, and then the edge color, let's use black. The fill color of the marker, let's use red, and then the marker size is 10, right? And then this G function, the call to the G function handle is gonna return a function handle to the geoplot function, right? Let's call it h2. So h2 is gonna be like that, right? And now we can actually use h2, right? We can use h2. Let's just create a new figure 2, and then just call h2 x and y, right? Hold down the control key and then press enter to execute this particular cell, right? So that's going to be black lines connecting red diamonds with black edge color and red face color, right? So that's how we can actually use str to func to actually get a handle that's pointing to a particular function, right? That's specified by using this particular string as the input, right? And then if we wanted to take a look at what this let's just func name equals to func to str. So this is really not necessary, and what I'm trying to do is to just to show you how to actually use func to str to actually get the name of a particular function handle, right? So if I hold down the control key and press enter to execute this particular cell, then I'm supposed to have a func name, right? Func name, that's a string, and then the value that's stored inside of this func name is supposed to be getPlot handle, right? Right. That's get plot handle. That's exactly what we are expecting. Right. So str to func and func to str, those two functions, this pair of functions allows us to actually use strings to get to function handles, and then to use function handles to get the name of the function. Sometimes if we sort of lose track of the process, right? There is one more Matlab intrinsic function that's going to be really handy for us to when we are actually dealing with function handles, which is called functions, right? So the name of this particular Matlab intrinsic function is called functions. So that's kind of confusing, right? So if we type help functions, then it's going to tell us how to actually use these functions, right? So this functions function is going to take a function handle as the input, and then it's going to return in something that's called a Matlab structure. And then what's actually inside of this particular thing, right? It's the function name, the type, and the other information about the function handle. So it's not just the name anymore, right? So func to str allows us to actually get the name of that function this function handle is pointing to. So the functions is going to return slightly more information, right, about the particular function handle, right? It's going to actually return a Matlab structure, right? What exactly is a Matlab structure, right? So far we have talked about matrices and vectors, right? We talked about the strings, we talked about doubles, those kind of elementary data structures, right? The matrices and vectors are not exactly elementary, but you can think of them as some kind of uniform composite data structure inside which you have smaller containers, right? All the smaller containers are kind of uniform. Every small container is just a container for a tuple, right? A matrix, a vector is just lots of those small containers combined together, right? But sometimes you want to store different kinds of data, right? So suppose you want to have a data structure that allows you to actually store, for example, the information about a person. A person has name, right? That's a string, right? And then a person has an age. That's an integer, right? And then a person may have some kind of vital signs, for example, blood pressure, heartbeat, that kind of thing. That could be integers or could be floating point numbers, right? So in this kind of case, you have a heterogeneous data type that has to be combined together into like one thing, right? And Matlab structure is one of the ways for us to actually store heterogeneous types of data together, right? So Matlab structure is a composite data type with smaller containers inside of it, and all those smaller containers can have different types, can store different kinds of data, right? So it's not like a matrix or vector that have smaller containers inside of it, and all of them can just store one type of data, right? For example, the double, right? So we're gonna spend some time to talk about the Matlab structure and also the CO array, which is another kind of a heterogeneous data type. So we'll talk about that when we come to a later lesson, right? So what this function is going to do is just going to return those information about this particular input function handle as a Matlab structure. It's not really that difficult to use the structure. So if you want to look at let's call it g_info. G_info equals to what? Functions. Let's use g as input, right? And then h_info is going to equal to, we have more than one function handles in our script, so let's just use h as the input, right? And then let's hold down the control key and execute this section of the code. And then we're gonna have two Matlab structures called g_info and h_info, right? And let's look at what's actually inside of these two composite data structures, right? Let's look at what's actually inside of g_info. So if we type g_info in the command window, it's going to show us g_info is a struct. So it's a Matlab structure. Struct is a shorthand notation for Matlab structure with fields, right? So the smaller containers inside of the struct big container is called fields. And then the fields, you have three different fields. One field, one smaller container is called the function, and it's gonna store the name of that particular function as a string. You see the single quote here, so it's a string, right? And then the second field, which is another small container inside of this struct big container, is gonna store another string that's called a symbol, right? And then there's one more field that's called a file, right? And then the file is gonna store another string that's gonna store the entire path, the absolute path where this particular file is actually stored. It's on the C disk, users pchain desktop get plot handle.m. That's the particular absolute path of this particular file, right? That'sginfo. Suppose you want to get to one of those fields. For example, I want to just look at the function field of that ginfo. So how do we actually access that, right? We use the dot. Right? And then function. Then it's just gonna return the string that's stored inside of this function field, right? And then if we want to access the type field of this ginfo struct, we just use the dot again, right? It's gonna return the word symbol, the string symbol, right? And then if we want to use ginfo dot file, then it's gonna return the entire path, right? And now let's look at what's inside of the ginfo, right? So ginfo is gonna return something kind of similar, right? But it's slightly more complicated, right? So the function, the string that's stored in the function field is gonna be this kind of two-level thing, right? It's a string. It's still just a string, but it's a longer string with this kind of separator, right? So because it's a nested function, so it's gonna the Joe plot is nested inside to get a plot handle, right? And then the type is not simple anymore. It's called nested, right? And then you have a file, right? The file is the same. The file is the same because it's stored in the same file. And then you have another field that's called workspace. Let's look at what's actually inside of the workspace, right? ginfo.workspace, right? It's telling us it's a cell, right? It's a cell. When we talk about cell array and structures, we will be able to actually understand what this thing actually is, right? But for now, it's let's just not investigate further, right? Let's just stop here and not investigate further. So functions is another way for you to actually get more detailed information about a particular function handle. In the previous video, we gave a few examples about how Matlab's intrinsic functions can actually use function handles as inputs, right? In fact, function handles are used very widely in Matlab. In Matlab's own intrinsic functions, right? Matlab actually has lots of intrinsic functions. It encapsulates almost every algorithm that's used very widely in every discipline of science and engineering, basically. It's got lots of algorithms, right? And many of those algorithms and many of those Matlab actually intrinsic functions actually use function handles, right? So it's a function handle is like a very important thing to Matlab, right? So in order to actually grasp or understand many of those high-level features of Matlab, we need to have a very concrete grasp about function handles, right? So last time we looked at two Matlab intrinsic functions. One is called f0s, right? And then the other one is called what? It's called integral, right? Integral allows you to do integrations, right? And f0s is more or less like our f Newton 2 function, right? That's gonna help us to actually find the roots of functions, right? f0s. Oh, f0, I think. Right, f0. So these functions are just the two examples of many Matlab intrinsic functions that's gonna take function handles as inputs, right? So now let's look at the two more examples. One is called fmin bnd. Fmin bnd is a function, is a Matlab intrinsic function that allows us to actually find the minima of a certain function called f min b and d, right? So it's also a quite common task for us to actually find extreme values of particular functions, right? So suppose we want to sort of find the minimum of a certain utility function or cost function, right? If you are if you study economics, right? If you are trying to sort of design something that's gonna consume sort of minimum amount of energy, that's also a minimization problem, right? Sometimes you want to maximize a certain objective, right? So, but that kind of maximization problem can also be solved by minimization problem. All you have to do is to actually put a minus sign on the objective, and then you can just minimize the new objective that with the minus sign, and then the result is going to give you the maximum for the original objective, right? So this kind of minimization or finding extreme values of a particular function is also a very widely is also a problem that has to be that appears in very widely in every discipline of science and engineering, right? And f min b and d is called the single variable bounded nonlinear function minimization, right? So it's going to do a single variable minimization, and it's a nonlinear function minimization. And the b and d means it's bounded, so you have to specify some kind of interval for the function to actually be able to actually find where the minimum actually is, right? Let's look at an example. Let's look at the example, right? Let's look at an example. How to use this kind of minimization function, nonlinear minimization function, right? So what's going to be the example function that we're going to look at? We're going to look at the Humps function, right? Again, it's a Matlab intrinsic function. If you haven't used it before, let's just do a help Humps, right? Humps, a function used by those things, those other functions. So it's got a strong maxima near x equals to 0.3, right? And x equals to 0.9. Right? So Humps x is also going to return x with no input. Humps uses so it's basically just a Humps. It's basically just a function. It's basically just a function that's going to return some input and output, right? So let's look at what the Humps function actually looks. Let's make a plot of it. Let's xy equals to Humps, and then let's specify some kind of interval 0 to stride at 0.001. So we're gonna create a x and a y. That's gonna be the horizontal and vertical axis of the output of this Humps function with that's gonna be sampled on this particular interval, right? So it's telling me maybe so this thing is unnecessary. So let me get rid of the square bracket. So and then let's just create another figure 3, right? And then let's make a plot of it. Plot x and y. Let's take a look at what this function actually, the shape of this particular function, right? Hold down the control key and press enter. Okay, so this Humps function is going to look like that, right? So yeah, it's got a very strong maxima that's at 0.3, right? But it's also got some minima that's kind of between 0.6 and 0.9, right? Right. Let's see if we can use f min b and d to find what's actually the value of this minima, right? Let's see if we can actually do that. Right, let's go back to our script. Right. So in order to actually use f min b and d, we need to actually come up with a function handle, right? So let's call it h. We have used the h variable already, but it's okay. We can just reuse it, right? We're just gonna put a different function handle into this h container. H is gonna equal to at Humps. Right. And then the minima that's called x min is gonna it's supposed to be located between like 0.6 and 0.7, right? So let's call it x min and then let's use f min b and d to try to find it. So h is going to be our function handle. So do you really have to sort of create an explicit function handle by using this line, right? It may not be necessary, right? So if it's just like that without any kind of specific inputs, then what you can do is to just put Humps with the at symbol in front of it. Then that's also going to work, right? but the reason that I'm sort of trying to explicitly create the function handle is just for demonstration purposes. And then this fmin bnd is going to take a second and a third input. That's going to specify the range where we want to find the minima, because a function may have multiple minima, right? It could have, for example, if you are trying to find the maxima, then it's got multiple maxima, right? So this is one maxima, that's like the global maximum, right? But there's another maxima, that's like a local maxima, that's around 0.9, right? So if you specify a range, and then fmin bnd is gonna try to find the minima and the maxima, minima or maxima in that particular range, right? So suppose we give it a range. Let's go from let's just give it 0 to 1, because for the entire range we have just one minima, right? Local minima. This doesn't count because this is on the boundary. Let's just find out what Matlab is gonna do, right? Let's give it a try. I'm not exactly sure, so let's just run it and see what's gonna happen. Right. Hold down the control key and then press enter. Now we are supposed to have xmin, right? Xmin. Let's see what xmin actually is. It's 0.6370, right? 0.6370. That's exactly a point that's between 0.6 and 0.7. That's this minima, right? So it was able to actually find this particular minima, right? So suppose we want to find the maxima. How do we actually do that, right? How do we actually do that, right? So essentially we have to sort of define another function. Let's just define h, right? Hx. That's an anonymous function, right? What it's gonna return is humps x, and then let's put a minus sign on it, right? So it's gonna return minus humps x. So h is gonna be pointing to a some kind of anonymous function, right? And this anonymous function is gonna take one input that's called x, right? And then the body of this anonymous function is gonna be minus humps x. So we're passing this input to the anonymous function direct to the humps function, right? And then the humps function is gonna have an output, and then we put a minus on it, right? And then let's still see maybe it's not gonna work. Maybe if it's not gonna work, then we can try to find out why, right? 0.3004. So it looks like it was able to actually find the maximum, right? So right. So what fmin bnd is gonna do is to try to find the minima of this h function handle. The h function handle is the humps function with a minus sign on it, right? So the minima of this h function handle corresponds to the maxima of the humps function. Do you see? So by finding xmin, what we're actually trying to do is to actually find the maxima of the humps function, right? Within this particular interval, that's 0 and 1, right? And fmin bnd was able to do that, right? And that's another very useful Matlab intrinsic function that allows us to identify the extreme values of a particular function, right? So maybe this global minima, global maxima is not exactly what you wanted, right? Maybe you want this particular maxima. Let's say from point A to 1. Let's give it a try, right? Let's change the search range and see if it will be able to actually find the. So it's 0.8927. 0.8927. That's very close to 0.9, right? So it was able to actually find this particular extreme, this local maximum, right? Okay, so that's fmin bnd. That's fmin bnd, right? So last time we looked at the integral function, right? The integral function, and the Matlab actually provides more than one numerical integration routine. So another one is called quad. It's also doing numerical integrations, but it's so you can sort of see it, right? It's a called oh, okay, so it's an old version. It's an old version. So now it's actually sort of trying to use integral instead, right? So quad is not really it's deprecated. So last time we talked about the integral, right? Um, so now integral is gonna sort of be a better implementation. So quarter was is going to be deprecated, I guess, right? So let's not talk about a quarter anymore because we talked about um, integral already, right? Last time. Um, Now let's look at how we can actually do double integrals, right? And double integral, Matlab actually provides a function that's called integral 2. So it's called integral 2. Right? And you can sort of see there's a triple integral that's called integral 3, right? So you can do double integrals using Matlab also, and triple integrals, right? So usually this kind of a double integral appears as so you have to specify a function, right? And then um, if you have two independent variables, if the function has two independent variables, say x and y, and then the value of z depends upon the value of x and y, right? So z equals to f x y, right? So let's suppose the function that we're trying to solve is z equals to f x and y. So it's got two independent variables, right? And the form of the function, it looks like exp 10 times x, and then dot multiply tangent of y, suppose, right? It's a function that has been used before by other people to demonstrate this kind of double integral. It's just I can't remember what the why they actually use this particular function. But it's just some arbitrary function that you can use to demonstrate the integral, right? Demonstrate the integral 2, double integral, right? So now you have two independent variables, x and y. So when we actually do the integral, we have to integrate over both x and y over a certain range, right? Um, so integral 2 is going to allow you to specify both the function, right, which could be this particular function, right, and then we need to pass a function handle as the first input, right, and then the range of x min and x max, the range of x, and then y min and y max, the range of y over which you want to do the integral, you want to do the double integral, right. The problem in this kind of double integral is that sometimes the range of integration is not really a rectangle, right? So x min and x max, for example, x min equals to 0 and x max equals to 1, right? So the x range goes from 0 to 1, right? But then y min and y max could be kind of dependent upon the value of x, right? So let's try to find out. Let's try to find out how do we actually use integral 2, right? In principle, you can actually specify y min and y max also as function handles. So that's going to allow us to actually compute the boundary of the integral based upon the input x values, right? And then at this point, function handles becomes really convenient, right? So suppose let's take a look at what this function actually is going to look like, right? Let's try to make a plot of it. Let's try to make a plot of it. So small x equals to let's specify the range of small x. Let's go from 0 to like 0.01 to 1, right? And then y equals to 0 to 1, right? And then let's use mesh squared to create the two-dimensional mesh x and y, right? Small x and small y as input, and then capital X and capital Y as output. And then capital Z is going to equal to exp 10 times capital X, and then dot multiply tangent of capital Y. So all these calculations are component-wise. So it's a dot multiply, right? And then exp and tangent, the default behavior for all those intrinsic functions are kind of component-wise. So capital X and capital Y are matrices, right? So now we can actually make a plot of it. Let's just do a figure 4, and then let's do a contour. F, X, Y, and Z. Let's give like 30 contours or something, right? Yeah. Let's hold down the control key and press enter. So that's what this function is going to look like, right? this is not a good display, right? Because the horizontal and the vertical axis are like strongly distorted. So the horizontal axis is really long, but the vertical axis is like really short, right? So maybe a better way to do this thing is to do axis equal and then axis tight. Right? So that's actually the plot with the correct proportion. Right? So that's what this function is going to look like. So the color is going to represent. Maybe let me put a color bar on it. Right. So now I have a. Do I have a color bar? Why don't I see a color? Oh, now the color bar actually shows up. Took a while. So the color is going to show the value of z, right? The color is going to show the value of z. So we know that the z value is kind of large at this corner, and it's kind of small, close to 0, for the majority of the of this rectangular region. Right? But that's not the rectangular region. Suppose the rectangular region is not really the region that we want to do the integral. The region that we want to do an integral is sort of in a kind of a triangular region that's enclosed by this particular triangle, right? So let's hold on to this plot, and then plot the line. That's x and y, and then use black. Right. Suppose our integration region is below this black line. So x still goes from 0 to 1, right? But y has to go from 0 to whatever this line value actually is, to whatever is the y value on each of the point on this line, right? So we want to do an integral inside of this triangle. So how are we going to do that, right? How are we going to do that? And the integral 2, because it's going to take function handles as a range specification, so which makes it quite convenient, right? So let's define like 2 function handles, right? The first function handle, let's call it h. H is going to equal to, we're going to just use anonymous functions, and this anonymous function is going to take 2 inputs, and x and y. This x and y, those 2 inputs, are just the symbols, are just placeholders. It's not the same as these 2 vectors, right? So for this x and this y, these are 2 vectors, right, with numbers in it. But this x and this y are just the symbols that we use when we actually write the definition of a particular function. And then the expression of the function is 10 times x dot multiply tangent of y, right? And that's the function that we are going to use as the first input to integral 2. And then we're going to need another function that's going to allow us to actually specify the range of the y. So basically this line is what? This line is y equals to x, right? This black line is y equals to x. Right? So what we have to do is to define another function handle that actually specifies this line. So let's define another function handle. Let's call it y, b, and d equals to another anonymous function, x, and then the body of the function is just the x. So if we give it an x input, then this is supposed to give us the same. So it's gonna return y equals to x, right? And at this point we can actually call our integral function. So integral 2, right? Integral 2, and then the first input is supposed to be h. That's the function definition, right? X min 0, x max is 1, right? And then y min is still 0, right? But y max is what? Y min is still 0, right? So every time we do it for a fixed x value, say 0.4, y is supposed to go from 0 to this line, right? This line is what? This line at location 0.4, this line y value has value of 0.4, right? So the second input is supposed to be y, b, and d. That's another function handle, right? And then let's assign the value of the integral, the result of the integral, into another sort of variable. Let's call it integral result. Let's just call it result, right? Let's just call it result. Okay, so now we can sort of execute this selection, right? And then result is what? It's 1072.6, right? So um, for this particular function, you can actually do this evaluation maybe analytically, maybe I don't really know, but maybe you can do the analytic calculation by using calculus, right? But Matlab actually gives you a numerical integration result that's telling you what that value actually is, right? 1072.6. So that's how you can actually use integral 2, right? In principle, you don't really have to actually assign those anonymous functions into a function handle. You can just put the definition of the function handle here inside of this line, inside of the same line, right? Let's just cut it. And then this one, y, b, and d, we can just add x, right? And then we can delete these two lines, right? Oh, so semicolon, I have to get rid of this semicolon. And then if you just execute this line, it's supposed to give you exactly the same result, right? Right. So the result is still correct, right? So that's how you can actually use the integral 2, right? And this one function actually takes two function handles as input, right? And there are also other examples inside of the Matlab as intrinsic function that's going to use function handles or anonymous function handles to anonymous functions as inputs, right? But we won't be able to actually cover all of them in this one video. But later on, if we have problems that's going to use function handles, we'll show that. We'll show how to actually. We'll show more examples basically.